So now that we have talked about how we actually stop a task, how task goes from the running state to the finished state, we now talk about how we do the actual cleanup, which is basically a function that is called release task. And release task basically takes the task struct that is basically being, that task struct that is of the task that is to be cleaned, and starts doing the cleaning process. And the cleaning process is what we have described earlier, that, well, you do not want the task itself to be in charge of removing everything that is related to it. I mean, it does release the memory, but it does not delete the memory. So release task is the cleaner, the cleaning up task, the garbage collector. I mean, it's not a garbage collector in the Java sense, but it's basically the function that goes in and sees what tasks are in the in a finished state and cleans up the memory. And basically, if the memory is needed by other threads, then it would not clean it up. Okay, and release task basically does these steps to release the memory and clean up. So it calls an exit signal, which calls another has another call internally, which basically removes the PID to remove the process list. The process PID from the PID hash, which is basically somewhere where you have all the PIDs of the processes that are running. So now that part is removed, you no longer, this PID doesn't exist. You also remove the process from the task list, which is basically the doubly circular linked list we have been talking about. And then the exit signal, after basically unhash process, which kind of detaches the PID, you basically the exit signal releases any remaining resources used by now that task, and finalizes the statistics. Did it finish correctly? Did it finish due to some breaking some rules and so on, and does the bookkeeping. If that task was the last member of a thread group, so it was basically the last task in a group of threads that were running together, then release task notifies the leader that, well, there's nothing now remaining. You should basically terminate that thread pool, or that not that thread pool, but these threads, basically everything that is related to them. And then it basically frees the pages containing, for example, the kernel stack, the thread infrastructure, and deallocate any cache that has been allocated to the empty task. With this, we actually have covered everything that we wanted to talk about how tasks are handled in Linux. This will not be this is the video I intended to post yesterday, but I basically got it wrong because of my microphone. But now this is hopefully better video, or a better set of videos. I will also record and upload videos today on system calls, or I mean, yes, well, today is not really today because it's probably tomorrow, Sunday. You will get videos on system calls and how they are actually used in Linux, so that you can basically start with assignment 1 if you have not already done so. I know that few of you have already done so, have thought about it, have read about it, and are probably, they might have even done the implementation already. But the coming video will hopefully make things even easier for everybody, including the people who have actually done it. Maybe they would like to revise what they have been doing. Okay, so thank you everyone, and see you on Tuesday, and talk to you pretty soon, and show you myself on a video.